Hi everyone, my name is Pariti Gupta and today we are going to learn a very important topic of operating system which is page fault handling mechanism. So, before we understand that what is page fault and how do we handle it, let's first understand what is virtual memory. Okay, so what exactly is virtual memory? Let's understand what is virtual memory. So what exactly is virtual memory? The actual physical RAM present is very small and the processes need access to a large memory, right? So in most modern operating systems, every process is given the illusion of having access to large continuous block of memory. This is made possible using virtual memory. It allows processes to access more memory than what's physically available by storing parts of memory on disk when needed, a concept which is known as paging. Okay, so here's the simple diagram. This is the so here this is the diagram. Virtual memory is divided into pages. This physical memory is divided. This virtual memory is divided into pages, and physical memory is divided into frames. The operating system maintains a page table here in between. It maintains a page table to map virtual pages to physical frames. Okay. Now we have heard about a new term, paging. So what is paging now? You have understood that what is virtual memory. But what is paging? So let's understand now that what is paging. In paging, the program is divided into fixed size blocks called pages and the RAM is divided into blocks of the same size called frames. See, memory is divided into fixed size blocks, pages, and pages which are virtual memory is divided into pages and physical memory is divided into frames. This is paging. Very simple. When a program is loaded, some pages are loaded into frames, but not all pages are loaded at once. Only the required ones are loaded. Why? Because we don't have a lot of memory, physical memory present there. So we only load the required ones. So what happens if the CPU tries to access a page that's not currently in RAM, in our main memory? So that's where page fault comes in. Okay. So page fault. Now what is page fault? A page fault occurs when a program tries to access a page that is not currently present in the main memory. Instead of crashing, the operating system steps in, fetches the required page from the disks, loads it into RAM, and then resumes the process. In technical terms, the CPU triggers a trap or interrupt, and control is transferred to the operating system. So पेज फॉल्ट ऑकर्स व्हेन रिक्वेस्टेड पेज इज नॉट इन मेन मेमोरी. सो क्या होता है बेसिकली, जब भी कोई प्रोसेस यूजर ने कोई प्रोसेस रन किया और सीपीयू नाउ सीपीयू रिक्वायर्स अ पेज, सीपीयू गोज एंड फाइंड्स इट इन द पेज टेबल, पर सीपीयू को वो पेज मिलता ही नहीं है पेज टेबल में. तो बेसिकली सीपीयू वो पेज फाइंड नहीं कर पा रहे हैं, तो यहाँ पे पेज फॉल्ट अकर होता है. ओके, नाउ वी विल लर्न दैट हाउ this page fault is handled. So before we understand that how page fault is handled by operating system, let's first know that why page fault is caused. Okay, so there could be these three reasons of uh, occurrence of page fault. First is first time access to a page. ऐसा हो सकता है कि सीपीयू ने उस पेज की रिक्वेस्ट ही पहली बार की है, तो कभी भी ऑपरेटिंग सिस्टम ने वो पेज लोड ही नहीं किया है मेन मेमोरी में. सो दिस कुड बी द वन रीजन. नेक्स्ट इज पेज वॉज स्वैप्ड आउट टू डिस्क. ऐसा हो सकता है कि पेज ऑलरेडी प्रेजेंट हो रैम में, पर ड्यू टू सम रीजंस कि किसी और पेज के लिए जगह बनाने के लिए उस पेज से नए पेज को रिप्लेस कर दिया, तो अब वो पेज मेन मेमोरी में अवेलेबल नहीं है. ये हो सकता है सेकेंड रीजन. And the third reason could be illegal memory access, that page could not be loaded, could not be accessed by the user. So this occurs This causes segmentation fault. So page faults are normal, but too many of them can be a problem. Okay. So these are the causes of page faults. Now we will understand that how do we handle page faults. So steps in handling a page fault. We will understand from here. Okay. Yeah. So here we are. So now let's go step by step and understand how the operating system handles a page fault. Okay. Now the CPU generates a memory access request. The page table is checked. This page table is this page table is checked, and if the page is marked as not present, a page fault interrupt is raised. Basically, a trap is raised. Okay. What a trap. So trap is raised. Trap to OS. The hardware immediately traps to the operating system, suspending the current processor temporarily. So the current process is suspended temporarily. Now the control which was to CPU, CPU had the control. Now this control from user, अब सीपीयू ने मेमोरी एक्सेस पेज एक्सेस के लिए रिक्वेस्ट डाली, सीपीयू को वो पेज मिला नहीं, तो ट्रैप अकर हुआ, जो और जो कंट्रोल यूज़र के पास था, वो कंट्रोल यूज़र से कंट्रोल ऑपरेटिंग सिस्टम के पास चला जाएगा पूरा का पूरा. नाउ ऑपरेटिंग now CPU will stop here and operating system will come in. Okay. Now the operating system checks that if the memory access is valid, if the program tried to access an illegal page, जैसे कि मेमोरी ऑपरेटिंग सिस्टम जो वो चेक करता है कि जो मेमोरी एक्सेस करने के लिए सीपीयू रिक्वेस्ट कर रहा है वो वैलिड है या नहीं. अगर वो इलीगल है तो फिर वो टर्मिनेट हो जाएगा एंड इट विल बी नोन एज सेगमेंटेशन फॉल्ट. ओके. But if it's valid, if the access is valid, then the operating system continues to handle this page fault. तो अगर जो भी रिक्वेस्ट किया है वो वैलिड है तो फिर ऑपरेटिंग सिस्टम जो है वो पेज फॉल्ट हैंडल करना कंटिन्यू करेगा. ओके. Now operating system will go in secondary memory here and it will find the page which is requested to access by the CPU. Now if it finds the page, like here CPU requested to access this page, operating system has found the page in the secondary memory. So what it will do is it will look for an empty frame in this table in main memory. Okay, it will look for an empty, oh sorry, it will look for an empty frame here. It will look for an empty frame here in this particular area, and here we can see that an empty frame is present, this one. So if there's a frame in memory, the operating system loads the page into it. If not, like here तो यहाँ पे तो एक free frame present है, पर अगर free frame नहीं है तो फिर operating system uses page replacement algorithms like first in first out or least recently used to decide that which page is to be removed. Like अगर ये सारी frames, this 1 2 3 4 5 6 7 जितनी भी फ्रेम्स है ये सारी अगर फुल होती तो फिर इसमें से कोई एक भी पेज, इसमें से किसी एक फ्रेम के पेज को रिप्लेस करते विद दिस वन एंड हम इस वाले को यहाँ पे लोड कर देते हैं. Okay, but for now we have a free empty frame here. So what we will do is we will read this page from secondary memory. Okay, wait, let me just change the color. Yeah, we will read this page from secondary memory to our RAM and we will put it here. Now we're having this page 1 in our main memory. This is an input or output operation. This is an in and out operation and can take milliseconds. So this is the slowest part, reading the page from secondary memory to main memory. Okay. Now after the operating system did this, after the operating system takes the page from secondary memory to the main memory, it updates the page table. It updates the page table. The page table is updated by the operating system to reflect that the page is now present in memory and its frame number is recorded. Okay. Once whole of this process is done by the operating system, the control is again switched from operating system to user, which basically means to CPU. Now the instruction that caused this trap. Oh, so now the instruction that caused this trap, this instruction that caused this page fault is restarted and the program resumes as if nothing happened. Okay, let's take a recap that what we understood in this whole slide, how this page fault is handled by the operating system. Okay, so what happened first is CPU requested for an access, CPU requested memory access, CPU ने memory access request किया, but the page was marked as not present in the main memory. So a trap to OS occur. Now the control from user is shifted to operating system. Now operating system will handle this page fault. This page fault has occurred and now operating system will handle it. Okay. Now first of all operating system will check that whether the memory access whether the request of the memory access is valid or not. If it's invalid, then the segmentation fault will it will be known as segmentation fault. And if it is valid, then operating system will go to secondary memory. This is logical address space. Operating system will go to this secondary memory. It will find the accessed memory, find the page which needs to be accessed. Then it will load this page from secondary memory to main memory. In our physical memory, if there is no free frame, if there is a free frame, then it can load that page to that free frame. And if there is no free frame, then it will use some page replacement algorithms and will remove any of the pages from the table from the physical memory, and it will replace it with the accessed page. After loading the accessed page, operating system will update the page tables to reflect that the requested page is present in the main memory, so that CPU could know. CPU तो page table को ही देखेगा ना, तभी से पता चलेगा कि main memory में कुछ है या नहीं, वहीं से वो मैप करता है. तो पेज टेबल अपडेट कर देगा ऑपरेटिंग सिस्टम. वंस ऑपरेटिंग सिस्टम डू होल ऑफ दिस प्रोसेस, द कंट्रोल इज अगेंस्ट शिफ्टेड टू यूजर. अब यूजर जिस रिक्वेस्ट की वजह से, जिस इंस्ट्रक्शन की वजह से ये पेज फॉल्ट हुआ था, वो इंस्ट्रक्शन वापस से रीस्टार्ट होता है एंड नाउ सीपीयू फाइंड्स द page in the main memory. So this is how page fault is handled. I hope you might have understood that how page fault is handled by the operating system. So even now, even if now you have some doubts, like it's not clear that what is happening, let's understand a real life example. Let me simplify this with a real life example. Okay, wait. So imagine you are studying at your desk with limited space. You only keep the most needed books on the desk. The rest are on your shelf. So let's assume that your desk is our main memory, RAM, and the shelf in which rest of the books are kept, let's assume that it has a desk, our secondary memory. Okay. So if you suddenly need a book which is not present on your desk, कि वो जैसे कि वो main memory में नहीं है, अब what will you do? You will stand up, you will go and find it in your shelf. You will come back and you will put it on your desk. If there is no space, then you will replace a book with the new book. Okay. So that delay, and then you will resume studying. तुम पढ़ते पढ़ते रुक गए थे, तुमने बुक ली और अब तुम वापस पढ़ने बैठ गए हो. So that delay is exactly like a page fault. It slows you down but lets you continue. Okay. And you handle, like operating system handles the page fault, here you handled your issue, whatever happened, right? You didn't found a book, you stood up and you just found your book in the shelf and you replaced the book. exactly this is the same thing what operating system is doing. Okay, I hope now you might have understood by a real life example. So page replacement algorithms, as we have seen, I've already explained that why we have to do page replacement. If there is a frame, then we don't have any need to replace any page. But if it's not there, but if the main memory is full, then we have to replace a page. So when memory is full, we need to remove one page to make space for another. Obvious, right? That's called page replacement. Some common algorithms which we use, which are mostly used, are first in first out. First in first out removes the oldest page which was loaded in the secondary memory. Then second is LRU, which is least recently used. Sorry, it was least recently used. So least recently used removes the least recently used page from the main memory. Okay. Third is optimal. Optimal replaces the page that is not used for the longest time, that won't be used for the longest time. This is only theoretical. Okay, these strategies help the operating system reduce the number of future page faults. Now, we know that page fault is very normal, but too many page faults are not good for operating system, because if a program causes because what happens if a program causes too many page faults repeatedly, the system spends more time swapping than executing. Like it has to make space for new pages, right? So it has to swap pages, use page replacement algorithms. This is called thrashing. Its thrashing slows down the entire system and is something the operating system tries to avoid by adjusting page allocations. So this is thrashing. I hope you might have understood it. This is all about page fault. How do we handle, how operating system handles page fault handling mechanism of operating system. So we are done with this. Now let's recap. Let's take a quick recap that what we understood in the whole of this video. A page fault, first of all, we understood that what is virtual memory. Then we learned a few basics of paging, that what is paging, and then page fault comes in, and we learned that a page fault, how page fault occurs, and what is page fault. So what is page fault? A page fault happens when a page is not in memory, right? CPU requests an access to a page and it is not present in the memory. That's when page fault occurs. How do we handle it? How operating system handles it? The operating system handles it by loading the page from disk to RAM. It uses Operating system uses page replacement if memory is full. We saw some page replacement algorithms. Then the last topic was thrashing. So too many page faults equals to thrashing equals to bad performance. Understanding this gives you a clear view of how memory management works behind the scenes. Okay, I hope that this video has helped you understand the page fault handling mechanism. Give it a thumbs up if it helped you. Thank you.